For thousands of years, Mercury, the closest planet to the Sun, remained an enigma, a small, swift world whose secrets seemed just out of reach. Ancient civilizations observed it with wonder, but no one could truly understand it. The planet's proximity to the Sun made it nearly impossible to study in detail, and for centuries, Mercury stayed locked in mystery. It wasn't until the 20th century, with the advent of space exploration, that we began to unlock its secrets. But it wasn't until 2004, when NASA launched the Messenger mission, that we began to see Mercury up close for the very first time. Messenger, which stands for Mercury's surface, space environment, geochemistry, and ranging, was a mission like no other. To get to Mercury, Messenger had to travel through the solar system in a series of complex orbital maneuvers, using flybys of Earth, Venus, and even Mercury itself, before finally settling into orbit around the planet in 2011. After nearly 7 years in space, Messenger arrived at its destination, ready to give us the first clear, high-resolution images of Mercury's surface. These first images, transmitted from the spacecraft, opened a window to Mercury unlike anything we had seen before. Prior to Messenger, the only detailed views of the planet were limited to brief flybys by NASA's Mariner 10 in the 1970s. While those images gave us a glimpse of Mercury, they left far more questions than answers. Messenger, however, changed everything. When the first images of Mercury's surface were released, they revealed an astonishing and alien landscape. The planet's surface was a tapestry of ancient impact craters, rugged cliffs, volcanic plains, and bizarre features that had never been seen before. The surface of Mercury resembled the Moon's in many ways, covered in craters, scarred by impacts, and devoid of an atmosphere to erode the features. Yet, these images told a story of a planet with far more complexity than we had ever imagined. Among the most striking discoveries were the massive cliffs, known as scarps, stretching for hundreds of miles. Some of these cliffs rise up to a mile high, forming massive ridges that cut through Mercury's surface. Scientists believe these cliffs were created when the planet's interior cooled and contracted, causing the planet to shrink over time. As it shrank, the crust buckled, creating these dramatic cliffs. These scarps are not just geological features. They hold the key to understanding Mercury's inner structure and its history. To give you an idea of their scale, some of these scarps stretch over 1,000 kilometers. That's roughly the distance between New York and Chicago. The cliffs may look static, but they are actually the result of billions of years of tectonic activity. They show us how Mercury evolved over time, offering us clues about how other planets might have formed and how the forces of cooling and contraction work on a planetary scale. Just when we thought we had Mercury figured out, Messenger unveiled another surprise: vast plains that covered large parts of the planet's surface. These plains are smooth, volcanic in nature, and spread across craters and basins. It was once believed that Mercury's volcanic activity ceased billions of years ago, but Messenger's images revealed evidence of volcanic eruptions much later in the planet's history. These volcanic plains suggest that Mercury's internal heat was still active far longer than scientists had originally thought, extending the planet's geologic life far beyond expectations. These volcanic plains aren't just relics of the distant past. Some of them appear to have been formed by eruptions as recent as 1 billion years ago, a blink of an eye in the geological timescale. It's a discovery that challenges what we knew about the thermal evolution of Mercury, and in turn, provides vital clues about the volcanic processes of other planets, including Earth. How long can a planet remain geologically active? The answer could be found in these vast plains, revealing the inner workings of a world that defies our expectations. But the real surprise came when Messenger turned its gaze toward Mercury's poles. Despite the scorching heat of the planet's surface, where temperatures can reach more than 800 degrees Fahrenheit, Messenger found something extraordinary hidden in the shadows of Mercury's poles: water ice. In these permanently shadowed craters, where sunlight never reaches, Messenger detected deposits of water ice that had remained frozen for billions of years. How could there be water ice on a planet so close to the sun, where temperatures can melt metal? The answer lies in these deep, dark craters at the poles, where the sun never shines. These areas, shielded from the sun's heat, provide a safe haven for water ice. The discovery of these ice deposits changes everything we thought we knew about Mercury. Could these frozen water deposits have played a role in the planet's geological processes? And what does this mean for the possibility of water elsewhere in the solar system? Another discovery that turned our understanding upside down was the revelation of Mercury's magnetic field. Most small planets don't have magnetic fields, yet Mercury, despite its small size, possesses one, a weak but significant magnetic field that scientists were initially puzzled by. How could such a small planet generate a magnetic field? This discovery raised profound questions about the planet's internal structure and its geological history. After examining the data, scientists found that Mercury's core is incredibly large. It accounts for about 85% of the planet's total volume. The core is primarily made up of iron, and its size and composition are key factors in generating the magnetic field. This large core could be partially molten, creating convection currents that generate the magnetic field. This discovery has deep implications, not just for Mercury, but for how planetary magnetic fields develop. Understanding Mercury's magnetic field can help us learn more about the origins of magnetic fields in other planets, including Earth. Mercury's core isn't just an anomaly. It also tells us about the processes that occur deep inside planets. With Messenger's data, scientists have been able to refine their models of planetary formation and core dynamics, shedding light on how smaller planets in the solar system may have evolved. Despite the incredible discoveries, Mercury remains a world of extremes. Its surface is bathed in intense sunlight during the day, with temperatures soaring to over 800 degrees Fahrenheit, hot enough to melt lead. At night, however, the temperature plummets to nearly minus 330 degrees Fahrenheit, colder than most places on Earth. These dramatic temperature swings, along with the lack of an atmosphere to protect the planet, make it an incredibly hostile environment for any form of life as we know it. Yet, these extreme conditions make Mercury a fascinating place for scientists to study. With each new image and every bit of data sent back by Messenger, we learn more not just about Mercury, but about the fundamental processes that shape all planets. From volcanic activity to magnetic fields, from water ice in shadowed craters to the internal dynamics of planetary cores, Mercury has proven to be a treasure trove of discoveries that challenge our understanding of the solar system. Although the Messenger mission officially ended in 2015 when the spacecraft ran out of fuel, its legacy lives on. The images and data it provided continue to shape our understanding of Mercury and inspire further exploration of the solar system's most mysterious planets. With the first real images of Mercury, we were given a glimpse into a world that's far more complex, far more dynamic, and far more fascinating than we ever imagined.